It's pretty common for old satellites and other space junk to come falling back down to Earth. But while hundreds of pieces of debris come down each year, scientists are nervously watching a 19,000-pound Chinese space station's course because its out-of-control route is making it impossible to figure out where it will crash, CBS Denver reports. The unmanned space lab named Tiangong-1 is expected to crash back down to Earth at some point in March. China reportedly lost control of the lab nearly 2 years ago, in June of 2016. The Chinese government later released an estimate that predicted Tiangong-1 would come down at some point in late 2017. The vague guess has led experts to conclude that the country's space agency has lost all ability to direct the crashing station's course and know where it will land. According to a November analysis by the European Space Agency ESA, the spacecraft's orbit will inevitably decay sometime between January and March 2018, when it will make an uncontrolled re-entry. Even a couple of days before it re-enters, we probably won't know better than 6 or 7 hours plus or minus when it's going to come down, Harvard astrophysicist Jonathan McDowell told The Guardian in 2016. Not knowing when it's going to come down translates as not knowing where it's going to come down. While much of the spacecraft would likely burn up in the atmosphere, ESA experts say portions could survive and reach Earth's surface. China's Long March 2F rocket carrying the Tiangong-1 module, or Heavenly Palace, blasts off from the Jiuquan Launch Center in Gansu Province on September 29, 2011. According to reports, there is only a 1 in 10,000 chance that the massive space lab will actually crash into a populated area and damage buildings. While the odds are slim, scientists have only been able to narrow the crash zone down to between the 43 degrees north and 43 degrees south latitudes, an area that still includes parts of every inhabited continent on Earth. The date, time and geographic footprint of the re-entry can only be predicted with large uncertainties. Even shortly before re-entry, only a very large time and geographical window can be estimated, said Holger Krag, head of ESA's Space Debris Office.